Determining functions. Key concepts. A relation is a pairing of numbers in one set called the domain. The numbers in another set are called the range. A relation, often represented as a set of ordered pairs, is x, comma, y. A relation is a relationship between two sets of data. And a relation is not a function when the domain value x maps to more than one range value y. What is a function? A function is a relationship between two sets of data where each input only has one output. And here's an example that's called mapping. Each neighbor is mapped to a car. In this case, the neighbors are from A to E and they're mapped to cars 1, 2, and 3. So we know the domain is the set of x values that are valid for the function, and the range is the set of y values that are valid for a function. Here's an example 2. We have the set 1, 2, 2, 3, 4, 5, and 6, 8. Here the domain x values are 1, 2, 4, and 6, and the range values are 2, 3, 5, and 8. Here are some more examples. In this case, we have a table that is representing a function where the domain is the set of x values that are valid for the function, which are the inputs, and the range, which is the set of y values that are valid for the inputs. We also have an example of a mapping that also illustrates the domain, inputs, and the range, which are the outputs. They are both examples. Here is a table that is example 5 with the domain and range values. Here we want to determine whether or not this is a function. Well, we have 4 being paired up with 3, 5 being paired up with 8, and 6 being paired up with 4 and 5. Because of our definition of a function, this is not a function, and the reason being is because 6 is paired up to 4 and 5, which it has 2 y values, and it's only supposed to have 1 y value. Each input has only 1 y value. We can use a vertical line test to see if a graph is a function. A vertical line test is an imaginary vertical line swept across the graph to see if the line ever crosses more than one point on the graph at the same time. In this case, it is a function if it only crosses one point on the graph at the same time, and it is not a function if it goes through 2 points on the graph at the same time. Here we have a parabola that's reflected about the x-axis, and we use the vertical line test to see that if this is a function, and from what we can see, it is not a function because it touches the line in 2 specific points on this graph. Given that a parabola is reflected about the y-axis, we can see that it is now a function, and that is because the vertical line test shows that there are no 2 points being crossed at the same time on this particular graph. Here is an example of a circle. Well, with the vertical line test, we see that it failed and is therefore not a function because it passes 2 points on the same line within this graph using the vertical line test. Here are some additional examples. So for number 1, we have 1, 3, 2, 6, 1, 5, 3, 8, and we want to determine if this relation is a function. Well, for every x value, we have only one y value, so therefore it is a function. For number 2, we have 2, 4, 4, 8, 6, 12, and 8, 16. This is also a function because for every x value, we have only one y value. Let's look at the table of the relation negative 3, 1, 1, 1, and 3, 1. Clearly we know that this is not a function because for every x there must be only one y. And in this case, each x value has the same y value. Here we want to determine if the following relations are functions and provide a reason why. So for number 4, we have 2, 1, 2, 5, and 3, 1. Once again, we know that in order for this to be a function, every x must have one y value, and in this case 2 and 3 has the same y value, which makes it not a function. Now here's number 5, which still appears to be a graph of a circle, and this is not a function because when we administer the vertical line test, it crosses the same line, crosses 2 points in this particular graph, which means it's not a function.